Welcome back to the lectures on DBMS. In the previous lecture, we talked about the importance of DBMS, history of DBMS, and the advantages of DBMS softwares over file systems. In this lecture, we talk about the earlier models of data modeling that were followed, and we talk about the levels of abstraction. When it comes to the data modeling, when people started thinking of modeling of a database, how we store the data, what should be the structure to store the data, they have several people have come up with several models. But the model that has seen the light and gained popularity is the hierarchical model. In this hierarchical model, data is organized in the form of a tree structure with starting with a root node. All the records are linked to the parent node with a link. Every record consists of the fields, and every record also consists of the sorted value, which to identify the record uniquely and in a particular sorted order as well. Not only that, every node may have several children, but every child will have only one parent. That is a restriction in the hierarchical model. This is done to identify the unique parent, to trace back and to move forward. It was used in the early days. And whenever new record is generated, the suitable parent is identified and a new record is attached at that particular location. This is how the data grows. It worked fine when data is limited. The hierarchical structure of the organization is fine, and a very clear-cut hierarchical picture is there for the organization. Then this model also works fine. But later, at later point of time, when it was being used widely, people have identified some difficulties with that. It is unable to capture many-to-many relations or many-to-one relation. This is only capturing one-to-many relation is taken care, one-to-one is also taken care, but one-to-many is okay, but many-to-many, many-to-one is not captured. So when there is a requirement of such kind of relationships to depict, this model is unable to do it. So people have identified it as a negative or drawback of the model. When people started observing the hierarchical model is not able to cope up with certain kind of relationships, then they have modified the hierarchical model and came up with a network model. In this model, it's an extension of the hierarchical model. The entire structure is similar to that. Only thing is it allows many-to-many and many-to-one relations as well, or one-to-many relations as well. So that every node now may have several parent nodes, and every parent node may have several child nodes. And common node, which is linked to the parent node, several parent nodes is also allowed. When this kind of relationships are allowed, then many-to-one and one-to-many, many-to-many types of relations are also taken care. But the problem with the network model is that as the organization grows, the network model and the depiction of the network model as it uses pointers to store has become very difficult and to manage, complicated to manage. So again, people started looking for new models. As the data grows, network model also, though it is capturing the relationships, it is not serving the purpose to have the quick queries. As hierarchical and network model fail, people started looking for newer models and newer ideas. At that point of time in 1970s, Edgar Card has come up with a new model in the name of Relational Database Management System. In this model, entire database is represented in the form of relationships of relations. Though it is based on a very simple mathematical technique of relations, but this has revolutionized the idea, and he has come up with certain rules called Edgar Card rules. And he was awarded Turing Award, Alan Turing Award, which is equivalent to Nobel Prize in Computer Science for this idea. And from that time onwards, entire world has changed to switch over to this RDBMS, and even now RDBMS is going to occupy the major part of the entire database management system. From 1970s to 2000, roughly 2008 and 2010, it has ruled the world, and no other model is able to beat it. Though several models have cropped up, but they are unable to beat this RDBMS model. In the later part of 2010 onwards, again, as I mentioned earlier, again, new thinking has come up, and NoSQL databases have picking up the ground, rather. So in these lectures, we talk about RDBMS only and relational database management systems only, and we'll have an elaborated view on this RDBMS system in the further lectures. Now we talk about the levels of abstraction of a DBMS system. How we can visualize the entire database management system and what are the levels or various levels that are present in it. If you look at the DBMS, it consists of three levels. One is the user level or the end user level or view level, it is also called. Another is a conceptual level or logical level, where the data is modeled, and the physical level where actually data is stored. So it can be visualized at three levels. Now, when it comes to the view level, it all deals with how user is perceiving or visualizing the database. If you look at example of IRCTC or a train railway reservation system, we can have various views of the same database. Passenger will have one view of the database. Whatever data that is being shown to the end user as a passenger is different, and whatever data that is being shown to a regional manager or a divisional manager or higher ups is different. Similarly, several applications may be built on the database, and applications are using the database and visualizing in a different form. For all of them, database is same. The inner database is same, but it is being presented to the end user in different forms. This is what exactly a view level is all about. Again, that view level can be accessed through different modes and different forms. One is application front ends through web forms or apps, or sometimes direct interfaces. So that is a view level through which users or end users are interacting with the database. Now, when it comes to the conceptual level, how actually data is modeled to be stored. So what model is being followed to store the data, and what is the logical structure of the data, and what is the logical connectiveness that exists among the data, where data is stored actually, how data is stored. So this all deals with the model part of the database, and this is completely independent of the end user. The end user do not know what is the logical structure of the database. As a passenger, I do not know what is the structure of the database for a railway reservation system, but I am able to use it as an end user. So that is called actually logical independence, where as an end user is unaware of the structure of the database. But ultimately data is stored in the form of a logical structure inherently. So there is a logical level. When it comes to the physical level, though you are visualizing the data in the form of a logical structure, maybe in the form of relational models or hierarchical model or whatever model that you follow, when it comes to the relational model, data is visualized in the form of tables, or relations or tables rather. So once the data is visualized in the form of tables, then how actually the data is stored, where actually data is stored. When it comes to the physical level rather, whatever logical structure that we are visualizing here is ultimately shall be stored in the form of data files. This logical structure, whatever we are visualizing, is only a virtual level, but actual storage of the data, whatever you are visualizing in the form of through a data structure of tables, is ultimately stored on the hard disks in the form of files only. So those files may be stored on several hard disks, which are located at different locations, which are connected through a network. So we are accessing those files, suitable files whenever required, and we are visualizing the entire data in the form of the model that we are presenting for the database, and that model is being used to build the queries. But ultimately, at the physical level, data may be stored in the form of data files only, relevant to the data model that we are describing in the conceptual level. So the actual storage is different, the logical level is different, and the view level is different. Again, end user is unaware of where actually data is located. Even if I change physical location of the data storage, end user should be unaware of it. That is called actually the physical independence of the DBMS. So this is how we can visualize all the three levels, and this is called levels of abstraction of the database management system. Yeah, by following these levels of abstraction, whenever there is a query from the end user or any operation from the end user, then based on the logical structure of the database, the suitable fields of the data where it is stored and how it is stored is being identified, and then corresponding files where actually the data is stored are identified in the physical level. They are brought into the buffer, they are processed, and then again the output is generated and is presented again back to the external level. So this is how the data flow from end user to the actual through logical level to the physical level, then from physical level through that logical level again it is presented back to the end users. That's how the data flow goes in the level three levels of abstraction.